Before we get started with this lesson, we're going to do a quick review on the two forms of a quadratic equation. The one we've been using a lot lately is our vertex form. And our vertex form looks like this: y equals a, x minus h, all squared plus k. And this one is very beneficial because this form allows us to see the transformations on our parabolas in terms of how the graph will look, and it also allows us to see our vertex directly from the equation. We also have standard form. And we've used it a lot, but we haven't referred to it as standard form a ton. But from now on, we're really going to work on using the proper terminology of vertex form and standard form. And our standard form looks like this. So yesterday, we were asked to go from here to here as part of one of our questions. And how we did that is we just multiplied it out. So we just expanded and simplified. Now, very often we want our equations in vertex form because vertex form gives us a lot of useful information. Understanding where our vertex is very beneficial in knowing where our maximum is, when it hits our maximum, and information like that. So, if I need to go from standard form to vertex form, we're going to do what is called completing the square. And that is what our next two lessons are going to be all about. So right now, we can go from vertex form to standard form, but we really want to be able to go from standard form to vertex. So that's the quick little piece of background that we need to talk about. So now we can get started on our lesson. So again, the standard form, like we said before, is y equals ax squared plus bx plus c. And we often want to find our vertex, so very frequently we will want our equation in vertex form. And like I said before, we do this by completing the square. So let's quickly start by doing a little bit of an investigation. And this part can be a little tricky, but what we want to do is we want to find the value of c here that will make each of these a perfect square trinomial. So just as a reminder, our perfect square trinomials are trinomials that can be written in the form a squared plus 2ab plus c squared. So what we need to do is we need to figure out what these c values would be to make this work. So you can try your best to see if you can see it. It's okay if you're struggling with this part because it is a little bit hard. But here, my a is 1x. So here I have 2 times 1x times something is going to give me c, and then I have to square that. So that will give me times 4. So the c has to be 16. So this part is very confusing. If you don't totally understand this part, that's totally okay. But give it a try on your own. See if you can find those c values and pause the video here, and then I'll give you a quick little formula on how to do that. So now we'll double check your answers. So for this one, we should have c equals 1, and we should have c equals 36. If you figured this out, awesome. If you haven't, what we're doing to find c is we're actually doing b divided by 2, and then we're squaring that. So that's actually what we've been doing the whole time. So if you try that with these examples above, it will actually work out. And this thing here is going to be very important in completing the square. You will not have to derive it like this again, but it does help a lot of people to understand where it comes from and that it isn't just a formula I pulled out of the air. So again, our goal of completing the square is we want to go from this and we want to go to y equals a, x minus h, all squared, plus k. Now, these can be a little confusing, and it does take a lot of practice to get good at it. So bear with me as we go through the first couple examples, and then you can start trying examples on your own. So the first thing that we're going to do is we're just going to write out our equation a little bit bigger so that you can see all of my steps. So step 1 is we need to common factor the x squared coefficient out of the first two terms. So if there's a 1, do not factor out the x. So what we're going to do is we're just going to put brackets around these first two terms. If there is a number in front of the x squared, we will common factor that out. For all of our examples in this lesson, we won't have a number there, but we will have numbers there next lesson. So just bear with me with that step for right now. It will make more sense in our next lesson. So that's the first thing. Put brackets around those first two terms. Now, what we're going to do is we're going to find c using the formula above. So let's start by doing that. So our magic number is going to use this number here, and we're going to divide it by 2 and then square it. So we take that -6, divide it by 2, and square it. So that will give us -3, all squared is 9. So that's the next step. Find our magic C number. And now we're going to add and subtract that inside the bracket. So all I'm going to do is I'm going to write out my equation exactly as it appeared before with my brackets. But now the change is I'm going to add that magic number we found and subtract that magic number we found. And the reason we add and subtract it is because that would be the same as me adding 0. So as long as I add it and subtract it, it will make it work out fine. So now what we're going to do is we're going to move this one out of the bracket. So let's rewrite this down here. So we had y equals x squared minus 6x plus 9 minus 9 plus 5. So again, we want to move this -9 outside of the bracket here. Now, when I move it outside the bracket, I always need to check if there was a number here. If there was, then I would multiply 9 by that. For these examples we're doing today, we won't have a number there, so that rule will be more applicable in the next lesson. So now we've moved that y to the outside, -9 plus 5. Now my next step is to simplify by adding the two constants together. So what we're going to do is we're going to add these two guys together, and we're going to collect some like terms there. So now we have y equals x squared minus 6x plus 9 minus 4. The next step is to factor the perfect square trinomial. So because of how we set this up, and because we found that magic number 9, we have turned this inside thing into a perfect square trinomial. So now we can factor it just like a perfect square trinomial. And if you're struggling with that, you can go back to our lessons in Unit 4. You can also factor this inside thing the same way we always do, by doing blank plus blank equals -6, blank times blank equals 9. And either way, you would end up with -3 and -3. So if you can't remember how to factor perfect square trinomials and you want to factor it the old way, that's absolutely okay. And now that I have my equation, I'm going to determine my vertex. So Remember, the x of our vertex is h with the sign switched, and then we can just write out our k. So those steps can be complex and they are hard. So we're going to do one more example, but you do need to just practice and practice and practice with it. So let's do one more example. So here's our equation. First step we do is we put brackets around the first two terms. Next, we need to find this magic number that we found. So that's step 2. So we take this number here, -2, divide by 2, and square it. So -2 divided by 2 is -1, squared is just 1. And now we add and subtract that number inside these brackets. So I keep x squared minus 2x the same. I add my magic number, I subtract my magic number, and that 1 at the end just hangs out. Next, I need to move this -1 outside of my bracket. It needs to move outside of the bracket. So that will give me x squared minus 2x plus 1 all stays the same. My -1 comes out of the bracket, and that plus 1 just stays at the end. Next, I need to collect these like terms at the end here. So my x squared minus 2x plus 1 all stays the same, and then -1 plus 1 is just 0. So I'm just not going to write anything. If you want to write a plus 0, that's totally okay. Now I need to factor the stuff in the brackets. Because of how we've set it up, it is a perfect square trinomial, but if you need to go through all the steps of factoring, that's absolutely okay. But if we factor like a perfect square trinomial, we'll have x minus 1 all squared. And now I can determine my vertex. So I will have my x is my h with the sign switched, and my k is my y value.